Hello everyone, I am Rainbow, roll number 179, and today we are here to solve example on partial identity of Fourier transform. So let's start with the first example, which is t square upon t square plus a square in bracket multiplied by t square plus b square, where limit varies from 0 to infinity. So let's consider that f of x is equal to e raised to minus ax and g of x is equal to e raised to minus bx. So here the Fourier sine transform of this, which is f of s lambda is equal to lambda upon in bracket lambda square plus a square, and here g of s lambda is equal to, now we will see the, we have seen the f of s. Similarly we will do for a g of x. The only one thing we will change is this a with b. So let's write that. Now we have seen the function f of x is equal to ax, and here their sine transform. After this, we will apply this into our partial derivatives Fourier sine transform formula. So we will write it as 2 by pi, where limit is from 0 to infinity. Now Fourier sine transform multiplied by gs of lambda, where with respect to d lambda infinity f of x multiplied by g of x, and with respect to dx. We have find out d, like e raised to x f of x g raised to g of x is equal to e raised to minus bx, and we have also find out the fs of lambda and gs of lambda. So we will put all of these in this formula, and we will see the further of it.
So hello, I have row number 180, and further we will put these values in our given equation. So we get 2 by pi, integration varies from 0 to infinity. We have a value of capital Fs of lambda, which is lambda upon lambda square plus a square, and further we have value of gs of lambda, which is lambda upon lambda square plus b square, and we have to integrate it with respect to d lambda. Also, putting values of functions f of x and g of x, we will get e raised to minus ax into e raised to minus bx with respect to dx. So after putting these values, we are going to solve this. So it will become 2 upon pi. Integration varies from 0 to infinity. We will multiply these two functions as lambda square upon, this become lambda square plus a square and lambda square plus b square with respect to d lambda, equal to this function will become integration varies from 0 to infinity. So as we know that the property of exponential functions, we can add the power of two exponential functions. Then by using this property, we can write as e raised to, by taking minus, and here x is common, we can write as a plus b. So after this, we will shift this 2 by pi in the right hand side. So we get integration varies from 0 to infinity, lambda square upon lambda square plus a square and lambda square plus b square with respect to lambda. So here by shifting 2 by pi in right hand side, we will write it as pi by 2. Then here we will take integration of this respective function. Then integration of e raised to minus a plus minus in bracket a plus b with into x is a plus b x, and we have to divide it by its coefficient, which is minus a plus b, and limit varies from 0 to infinity. Further, by substituting the limit, we will get, first of all we will put upper limit at the place of x, then we will know, as we know, e raised to minus infinity is 0. Therefore, the whole term becomes 0. And for lower limit, we will take minus, and substituting 0 at the place of x, we will get e raised to minus 0. E raised to means 0, and e raised to 0 is 1. And these minus become plus, and it become 1 upon a plus b. Bracket complete. And by solving this, we will get pi upon 2 in bracket a plus b. After this, we have to replace lambda by t, as our question is in term of t. So replace lambda by t. So we will get integration varies from 0 to infinity t square upon t square plus a square and t square plus b square with respect to t. We will write as pi upon 2 into a plus b. So this is a required solution for given equation.
I have roll number 181, and let's proceed with the next example of partial identity of Fourier transform. So our example is limit varies from 0 to infinity sin at upon t into t square plus b square with respect to dt. So here we have f of x. We have the f of x equals to e raised to minus bx, and fc of lambda equals to b upon lambda square plus b square, and also g of x equals to 0 less than equal to x, x is less than equal to a, and here x is greater than a, and our gc of lambda equals to sin of a lambda upon lambda. So we solve this example by putting the values of all these in the Fourier cosine transform, the formula of the Fourier cosine transform. So let using the Parseval's identity of Fourier cosine transform's formula is 2 upon pi limit varies from 0 to infinity fc of lambda into gc of lambda with respect to d lambda, and is equal to limit varies from 0 to infinity f of x into g of x with respect to dx.
Hello everyone, I have roll number 183. So now we continue our solving the solution of this function. Now we will substitute the among values from above, which is 2 upon pi integration varies from 0 to infinity. The value of fc lambda is b upon lambda square plus b square multiplied by gc of lambda is sin of a lambda upon lambda with respect to lambda, which is equal to integration varies from 0 to a f of x is e raised to minus bx, g of x is start, and g of x is a 1. Now which is this with respect to x. Now we are putting this b as a outside of the integration. Now we will get 2b upon pi integration varies from 0 to infinity sin of a lambda upon lambda square plus b square, which is multiplied by lambda with respect to lambda. Now this integration is 0 to infinity, 0 to a e raised to minus bx with respect to x. Now we will shift this term to the right hand side. The equation like this: integration varies from 0 to infinity sin of a lambda upon lambda into lambda square plus b square with respect to lambda is equal to pi upon 2b. This integration is 0 to a e raised to minus bx with respect to x. Now integration 0 to infinity sine of a lambda upon lambda into lambda square plus b square with respect to lambda is equal to pi upon 2b e raised to minus bx upon minus b. Limit varies from 0 to a. Now we will substitute the limits in the place of x. We will get integration varies from 0 to infinity sine of a lambda upon lambda into lambda square plus b square with respect to lambda is equal to pi upon 2b. Now as we all know, in place of x we substitute b, so we will get e raised to minus ab upon minus b minus lower limit starts from minus sign, but this minus and this minus sign gets plus, and we will get 1 upon b. Now this minus is absorbed in this bracket, and the whole equation will be changed as like this: pi upon 2b 1 minus e raised to minus ab upon b. This is the final answer in terms of lambda, but we have our function in the terms of t, so we will replace the lambda with t. After replacing, we get integration varies from 0 to infinity sine of at upon t in bracket t square plus b square with respect to t is equals to pi upon 2b 1 minus e raised to minus ab upon b. So this is the required